Hello, let us have a look. We have some elements, these elements are stored in an array or in some memory place, okay. 9, 10, 2, 5, 20, 60, 11, 80, whatever elements are there. Say for example, there are n number of elements, there are n number of elements. Here how many elements are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So, here n is 11. Now, I want to search some element, say for example, I want to search 9, this element we are trying for search, we are going for search. So, where it is? So, I will compare with the first element and the single go, in the single go I can able to find the element. Only one comparison is required. How many comparison is required to search 9? Only one comparison. How many comparison required? One comparison. Now tell me, if I want to search for 60, I want to search 60, how many comparisons are required? 1, 2, 3, 4, 5, 6, 6 comparisons are required. If I try to search 40, how many comparisons are required? You will say 11 comparisons are required. So, if I have 100 elements, so n is 100 and the element at last, the element is placed at last, say then 100 comparisons are required, because whenever we are trying to search some element, we will iterate through this loop. First we will compare with this element, we will run a loop, and through this loop we will just compare with the index 0 element, then index 1 element, index 2 element, 3, and this way we will continue till the last, unless we are getting the element. But do you have any better solution, better way of storing these elements, so that we can able to search the element efficiently or less than this time? Less than this time means if we are trying to find out the time complexity of this case, it is called big O of n. Big O is the worst case complexity of this particular case. Now, big O of n is the time complexity for this case, because n number of elements, the element can be present at last. So, the time complexity definitely will be big O of n. Do you have any other arrangement by which you can able to arrange all these elements and we can able to search the element with minimum time? Do you have it? If yes, just think about it and then pause your video and think about the solution. Now, if we try to arrange these elements, so these are my elements, okay. Now, we are trying to, we have what element we have 9. What we are trying to do, we are storing 9 here, first element here, and then 10 here, then 2 here, 5 here. Now, what is this? I will explain later. Then 20 is here, then 60 will be here, 11 is here, then 88 it is here, 30 it will be here, and 40 it will be here. 20 greater than 60 less than, so it will be 40 will be here. So, do we have? Yes, we have a better solution. Now, look, if we try to search any element, how many comparisons are required? So, if I try to search 9, the first element, okay, the 1 unit time is required. Now, if I try to search 40, this element, how many comparisons are required? One comparison with this one, because all the elements, what arrangement we have made all the arrangement, the greater, if I have created some place and the right side we have placed the greater element of this element, and the lesser elements are placed its left side. So, left elements are lesser than this and right elements are greater than this. These are lesser than LT lesser than, and these are greater than this element. So, first one comparison 2, 3, it is greater, it will be 2, 1, 2, 3, 4, 5, with 6 comparison I can able to find out the element. Yes, the arrangement is efficient now. So, by this way we are able to search the element in an efficient way. So, in this case, the time was taken in, that is 11 unit time is required, that is 11 comparisons are required, or 11 time the loop is iterating. Here it is iterating less than that. So, this architecture is called tree data structure. This specific architecture is called tree data structure. Now, in case of this tree data structure, whatever we have some elements like this, we have some element like this. This is called tree. This is called tree data structure. Now what are these? This is called the node. This is called a node. Everything is called a node. This is called a node. Everything is called node. And one tree can have multiple values. So, this is node. This node can have one or two different multiple nodes. This can have multiple values. This node can have multiple values. This node also can have multiple values. In your laptop or in your system, if you observe, there is a drive D. In this D drive, there are some folders. This folder is called, say for example, this is movie folder, this is education folder, this is some another or entertainment, this is education folder. There are so many other folders. Within education folders, you have C language, in this you have Java language, in this you have data structure. So, you have in this data structure, you have different folder for tree, for queue, for linked list, you have different nodes. So, how system take care about all these values? How system will store these values? That is the help of tree. If you write the tree command, in your command prompt in Windows machine, just write tree command and enter, you will see this type of structure will display. So, the arrangement how the values are stored, that is called tree. So, if the tree can have multiple nodes, then this is nothing but the larger version of our double linked list. You can say, so if this is, say for example, this is a node, this node can have some value, say for example 20 is the value. This node can have multiple values also, say for its address is base address 7000, so 7000 is here. This node is, this is 9000, another value, it is pointing another value. This is 5000, these are the base address of other nodes. So, this is nothing but the structure how the values are actually stored. What are the applications? The application of this particular tree data structure is huge in our database management system, where we store the data in physically in our secondary storage. How the data, how the tables are actually stored physically in our database. In that cases, in our this is in case of database, we have huge applications. In case of artificial intelligence, AI, we have a tree, you have an algorithm, that algorithm is called decision tree, and in many other cases also. In case of parsing, in our compiler design, you will have a parsing is a module, parser is a module. In that module, we use this particular data structure, and we have huge applications of this particular data structures. Now, whenever one tree, this is called a node, one node can have one child, these are called childs. That is the single linked list we have discussed, that one node, again another node, again another node, that is called the single linked list or double linked list, there we have. But here one node can have two different childs. So, this is called left child, this is called right child. One node, this type of tree is called binary tree. Bi means two, only one node can have two different childs, and this one is called a root node. This is called root node. One root can have three different childs. One tree can have four different childs, and this way there can be called n-ary tree, n-ary. So, one root can have two childs means the base address or the base address of two different locations, and there can be n-ary, there can be three, there are tri, then tetra, penta, or and this way n-ary, and this way we represent all these things. Now, in case of binary tree, we have the arrangement like this, that one tree can have maximum of two childs. These are the two childs. One tree can have maximum of three childs. These nodes this is called a root node. This is called a root node. These are called internal nodes. These are called internal. These are called leaf node. These are called leaf. This is also leaf. This is also leaf. This is the node which does not have any child, that is the leaf node. That means in this case, if you observe carefully, this node is only having some value, but these address parts are nothing but null. Okay. So, in the next video we will discuss more about this tree data structure.